So we do a recap of what we covered last week while waiting on the others, and then we'll get into what we do this week. So last week we introduced vectors. We began by defining vectors and differentiating that from scalar quantities. And what we were saying is that vectors is a quantity that has both magnitude and a specific direction, right? So for example, we could represent 16 kilometers per hour west using this line. We call that line a ray, right? And we would draw the line and usually be pointing in a particular direction, right? Scalar quantities, which is unlike vector quantities, they only define or are fully defined by magnitude only. So we went on to distinguish between them, and some examples of scalar quantities included things like length. That's a scalar quantity, because if I ask you, what's the length of this pen, right? The length of the pen really just gives you the magnitude, meaning the size, right? Mass is another one. So I took my weight yesterday at the pharmacy. 61 kilograms. I think a slightly underweight. I should be at 64 if I'm not mistaken by my height. That's mass. That's just checking one thing, which is magnitude. Temperature again, right? Like currently we let's see. They say that we currently under a heat wave, right? You all know that. I keep telling all the classes, it's 34 degrees, feels like 40 degrees, right? So that tells us how hot or cold something is. So we're gonna have some very severe high temperatures over these next 2 weeks, right? Vector quantities, on the other hand, vector quantities, they have both magnitude and direction. So force is an example of a vector quantity. Force has magnitude, which we would usually quote in terms of newtons, and it tells us the direction. So we could, if I'm pushing a brick or block, or let's say I'm pushing a sandbag to the right, I could be applying a force of 30 newtons to the right. So we have both magnitude as well as direction. Velocity is another thing too. A velocity is another vector quantity that represents the object speed in a particular direction. Displacement, which is different from length, right, is a measure of the change in position of an object from its initial point to its final point. And that's a lot of what we'll be doing in maths, looking at displacement vectors. So that's how we distinguish between vectors and scalar quantities. We then went on to talk about representing vectors, and we say that it's represented by these rays that you're seeing on the screen, right? Apart from that, it can be represented by these bold letters, and for us, where we can't write bold letters in our notebooks, we just put a little line underneath it, right? Other than that, we could have starting and end points to help us determine the direction for this. So this vector here is the vector AB, because it starts from A and goes to B. We could tell that by the arrow. This one is the vector BA, because it starts from B and it goes down to A. We went on to learn about the magnitude of vectors, and there's two ways that we looked at it. We looked at vectors that are represented on a grid like this. And to find the magnitude of the vector, what we did is we looked at the horizontal displacement, how many blocks that's going this way, right? That's a total of 12 blocks. And how many blocks is going this way? A total of 5 blocks. And what we used was Pythagoras theorem, right? Basically, it's finding the square root all of 5 squared plus 12 squared, right? Same thing with the small one, 2 blocks this way, 4 blocks this way, square root of 4 squared plus 2 squared. And it doesn't matter the order in which you write that in, right? Because addition is commutative. We went on to do some exercises involving, these rays on a grid and finding the magnitude of those vectors. Then we said another way we could represent the vectors is using a column matrix. So that's a 2x1 matrix, 2 rows, 1 column. So these are all examples of column matrices here, right? And I asked you guys to find the magnitude of these vectors. So you simply did that by taking each one of these, squaring it, add it to each other, and then find the square root of that. And that gave us our magnitude. Yeah? Right, so you guys had this to do for me for homework, and you're supposed to upload it on the Google Classroom. If you didn't get a chance to do it during the week, you could still do so today, so I could take a look at it, make sure you understand. We talked about equal vectors. Equal vectors implies that they have the same magnitude and they have the same direction, right? Equal vectors have the same magnitude and same direction. They don't need to be represented by the same type of line segment too, right? So these here are examples of equal vectors. Negative vectors, if we change or we look to refer to a vector in the opposite direction of in which it's going, then we use the negative of the vector. So let's just say, for example, I had a vector that was going like this from A to B, but for some reason, let's just say, okay, let's say that A to B is 2, 3, right? So A, B, the vector AB, because it's going in that direction, is denoted by this column matrix of 2, 3. That's my vector. If I want to do, or I want to write the vector BA instead, then when I change the direction, I am actually just going in the opposite, so it becomes negative AB, right? And negative AB means that I'll just be multiplying everything in the bracket here by the negative sign. So it becomes negative 2, negative 3, right? So essentially, BA, which is the opposite of AB, is negative 2, negative 3. Do you guys understand that? This is important because the topic we're going to do today, when we change the order of or the direction, this is how you're going to represent it if given a column vector. You understand this last piece here? Just drop a Y in the chat board if you do. And if you don't, so I'll know to explain it again. So long as okay. Yeah, Julia, you okay with that? Carrie's alright with that? Good. All right, excellent. Sometimes we could also increase the length of a vector or double up on it by using a scalar, right? So for example, if this is A, we could multiply that by 2 and that gives us twice A. We could change the direction and multiply by negative 2, so it goes in the opposite direction. All right? Right. So the last thing that we looked at was the equivalent displacement. So looking at the movement of vectors from one point to another. And I give you guys an analogy of, traveling from Chaguanas to Port of Spain. I told you there's 2 ways you could do it. It could be a straight route from Chaguanas directly to Port of Spain, or we could do a Chaguanas to Curepe and then a Curepe to Chaguanas. That's essentially what these displacement vectors is about, and it's how we use the triangular law of vectors. So you would notice that for all of these questions, we are really representing it using a triangle. And if you look at the direction of the arrows, there's gonna be, we start at A and we want to get to C. There's the 2 routes. There's the direct route, like our Chaguanas to Port of Spain route, right? And then there's the Chaguanas to Curepe, Curepe to Port of Spain route. So we could go this way and then come back down this way, and we will still achieve going from A to C. I told you guys the way to write this is to start at A and we want to go to C. And there's always a common point in the middle, which is B. Right? That's like the Curepe junction. You get there and then they start from there and you go again. And this whole movement is the same as going from A to C, AC. And this is really the triangular row of vectors. And I broke it up into two steps for you. This was the exercise you did last week, right? So you was required to write the displacement vector for MP, JL, DF, RT. And we built it up the same way. I said, when you're doing it, if you're going to go from R to T, start with R, end at T, and then the number in the middle, the letter in the middle is always going to be the same, which is this common point here, S. So you go from R to S and then S to T, and that's equivalent of our total displacement from R to T, right? So we're going to build some more on this today, right? Where we did add in vectors and we use some letters, but we want to do something more than that today. We're going to introduce that movement that I was talking about when you go in the opposite direction. We're going to look at the parallelogram law of vectors, and then we're going to do some questions involving movements, right? So I want to get into, before I get into the parallelogram law of vectors, let's look at this question. We look at the example first. Find a single vector equivalent to AC plus CD, right? Now again, it's always good to see the common letter in the middle, and then you're going from A to D, right? So A, we're talking about going from A to D, right? Now we could go from A to D, and then from D to C. The equivalent vector that they're talking about is the vector AC. Sorry, my bad. Wrong thing, I'm off. Oh, wrong pen. A to C, and then C to D. It's gonna be A to D. Right? Let's look at this triangle here. Find the single vector that is equivalent of going from P to Q, Q to R. So where is P? P to Q is this way, and then Q to R is this way. So from P to Q, Q to R. The equivalent vector there is PR. Now, just as I show you how to write it, they just do it in the opposite here right now. You're going in reverse. So usually this is going to give you your answer. Let's look at another one. Right, so I'll put here 1A. PR is equal to PQ plus QR. Right, let's try B. B wants us to find a single vector that goes from P to R, and then R to Q. Look at that, we're going this way. So that's the same as going from P to Q. And again, you look at this, that's going to help you. Everybody see that? So they gave us an open triangle so they could ask multiple questions on it. You guys see that? Drop a 1. No? Okay. We look at it again. If I want to go from if I'm starting at P, this is P here, and I'm going to Q. So this is like we're traveling. And the example that I gave last week was that if I am in Chaguanas, if you're familiar with Chaguanas by KFC there, there's two things I could do if I want to go to Port of Spain. There's a highway car that I can take in Chaguanas that will take me straight up the highway directly to Port of Spain. There's no stopping, it's a straight trip. Or I could take a green band maxi and I could go from Chaguanas to Curepe Junction, come out of the green band maxi, take a red band maxi in Curepe Junction, and then go to Port of Spain. both routes, if I go from Curragh, sorry, if I go from Chaguanas straight to Port of Spain, or I do a Chaguanas to Curragh, and then I go Curragh to Port of Spain, I am still achieving that same thing of going from Chaguanas to Port of Spain. It's just two different ways or two different routes. It's the same thing happening in these triangles here, right? We are looking for our straight trip, which is Chaguanas to Port of Spain, and they have given us our broken trip, the Chaguanas to Curragh to Port of Spain. So think of these as your Chaguanas to Curragh, and you see you start here again from Curragh to Port of Spain, Chaguanas to Curragh, Curragh to Port of Spain, Chaguanas to Curragh, Curragh to Port of Spain, Chaguanas to Curragh, Curragh to Port of Spain. You see that, Shaniqua? Yeah, good. So what they're asking us to find is the straight route, which is the Chaguanas to Port of Spain. Now, in each of them, we're using different letters to identify that straight route. So if I do PQQR, this is P, so think that's Chaguanas. This is Q, think of that as being Curragh, and R is Port of Spain. So I go Chaguanas to Curragh, Curragh to Port of Spain. But that's the same as if I just took the one route from Chaguanas and I take the highway car and I go straight from Chaguanas directly to Port of Spain. So Chaguanas to Curragh and Curragh to Port of Spain is the same as going straight from Chaguanas directly to Port of Spain. This is my straight route, or my single vector that is equivalent to this, because they're both equivalent. They both achieving the same objective of going from Chaguanas to Port of Spain. Does that make sense to you now? Yeah, nice. So let's look at another one. So they could just change around the letters that we're using here, right? In part B now, this is our Chaguanas. This is our Curragh. So I go Chaguanas to Curragh, Curragh to Port of Spain. The straight route now is just labeled something different, which is PQ. So this is Chaguanas to Curragh. See, start back here again in Curragh to Port of Spain. So the straight run from Chaguanas to Curragh now, from Chaguanas to Port of Spain now, we just change the letters to PQ instead. Follow? Everybody okay with that? Everybody following that? Yeah?
Yes, sir.
Okay, nice. That's now I need to. I have to cut out some more questions. Get some more questions. You guys you get a lot of practice. All right. So tell me, right? For C, we have R. Now look at how I do Tony diagram, right? We're doing R. So that's my Shogunas, the QF, Q, and then Q to P. Now pay attention to something. These two is like a QF. This is your Shogunas, this is your Porter spin. So if I'm looking for that single vector or that straight trip up the highway, that's going to be the R, which is Shogunas, the P, which is Porter spin. You see it? Everybody see now?
Yes, sir.
So RP is my single vector to represent R going to Q and then Q going to P. And last one, if we do Q now to P and then P to R, that's the same as going from Q straight to R. So QR is equal to Q to P plus P to R. That's this. Yeah, everybody okay with that? So let's
Yes, sir.
try let's try one on your own. So give an alternative route for AB, right? An alternative route for AB. So all of these here is telling you this is a straight route now, right? So we could look at it both ways. We could look at it either as how it was in the questions before, right? So tell me what the straight route is. Here they give you the straight route, right? This is the straight route here. 1 second. Where's my this is my straight route here from Chabonas to Port of Spain. And how can I do that? I can go Chabonas to Curep and then Curep to Port of Spain back this way. See that? Everybody see that one?
Yes, sir.
What about this one too? I want to go from A to B. I could also go A to D and then D to B. You must always have a QF junction where you have to come out and go in our next maxi to start from QF to go to tongue again, right? Alternatively, I could go A to C and then C to B. All right? Well, see that? Look at this one, A to B. I could go from A to D and then start from D now and go D to B. And I would still achieve going from A to B. Or I could go A to C and then C to B. Yeah? Everybody okay with that? Anybody confused? 1 second. Let's put a slide backward. All right, so try these for me. All right, let's take a look at these guys. So I'm gonna help you a bit here with these things, right? This is our resultant vector. We want to figure out a route to go from A to B, alternative route from A to B. Alternative to get from A to B. We want to start from here and get to B. So we could go from A to C. When we get to C now, we start from C and we go to B. Think about this as your start and end. How else can I start at A but still end at B? To start at A and still end at B without going directly from A to B. The alternative to that is to go from A to C and then from C to B. So AB, going from A to B, could also be achieved by going from A to C and then starting from C and going to B. Is that clear to everyone? Let's look at it here again with B. Right, B, we want to go from A and we want to get to B. So this is our start and this is our end. But how else could we start at A and get to B? If I start at A and I travel in this direction to D, this way, and then I start from D and I go to B, I would still achieve starting from A, even though I start at A and go to D, and then begin at D and go to B, I will still achieve that movement or that displacement of going from A to B. Alternative to that, I could also start at A and go to C, and then from C go to B. I will still start at A and end at B. Is everybody seeing that? Yeah? Leah? Dominic? Solana? Akari? Solana, you good? Seeing that? Akari, you too? So if I start at A and I want to end at B, how can I achieve that? I could start at A, I could go to C, and then I could start from C and go to B. So you see, it's still a triangle there. You see any triangles? Right? And it's a pattern. You're starting at A, going to C, and then you're starting from C and going to B. Right? So A to B, the result of going from A to B could also be found if we go from A to C and then from C to B. We could also start at A and then go this way towards D. And then when we get to D, we could then go to B. And we will still start at A and end at B. So I could write A to D and then D to B. Now there's something in common, or there's a property here that helped me a lot when I did this in school. If you notice, these middle points are always the same, right? Regardless of which route you choose to achieve this AB route, you have to go to one place, which is my QF junction, as I like to call it, and then start from QF junction to go to Portersfield. All right? Okay. Let's try this one. So here they wanted to identify, so they keep switching it, right? The last exercise, they told you list the two vectors to get to AB. Here, they're giving you that you're starting at A, then you're going to B, and then you're going to C. What is that movement here? That's the movement from A. And where are you ending? Where are you ending, guys? C. Very good. That's where we ended. So we are going from A to C. And that's the same as going from A to B and then from B to C. See that? So this movement here is our resultant vector. We use two arrows on it. See that? Everybody see now? Let's look at another one. A to B. So A to B, then B to C, and then C to D. You see now? Where are we starting? Where are we ending? We're starting here. Where are we ending? D. Very good, Shaniqua. We're ending at D. So our resultant vector A to D, which is this. Look at it. A to D. So A to D could be found by going from A to B, then from B to C, and then from C to D. We still achieving starting at A and ending at D. Yeah? Let's look at this one. This one here. We starting at B. Starting at B. This is my start. And then I'm going from B to C. And then from C, I'm going to D. Where am I ending? At D. So that movement from B to C to D is, look, you have to look at for the lines too, is the same movement as going straight from B to D. So you get BD is equal to BC plus CD. Yeah? Is everybody okay now? I want to move away from this a bit. I think you guys get me hang of it. So I'm going to make my own questions. So you want to take it a step further. Well, you always have to pay attention to the arrows, eh? So I have A here. This is B here, this is C. This vector AB is equivalent to 1, 3, right? That's the equivalent of that vector. BC is equivalent of 2, 4. So that's I'm giving you a value for the vectors now. I want you to find for me what the vector AC is. Right? We call this the resultant vector. Find AC. So I'll do this first one for, right? So this first step is to write the vector equation. And the vector equation is, if I want to find, what you want to find? You want to find AC, right? AC could be found by going from, look at it, A, starting at A, going to B, and then coming back to C. Make sense? Just drop a Y in the chat board if it does. Y in the chat board, right? Good. Now we have values. We have values for AB, right? And we have values for BC. I could write underneath here from the diagram. AB is 1, 3. And BC is 2, 4. So if I want to find what AC is, then I just need to add these two vectors together. So my resultant vector is AC is 3, 7. Is that okay? Just drop a 1 if you're okay with that. Yeah, all right, nice. So you can try 1 for me now. Right, always look at the direction of the arrows, right? Because they could change the direction of the arrows. And if you want something, you might need to adjust accordingly. I'll show you how to do that just now. So here I want you to find MP, right? Make sure and state what you have from the diagram. Right? State that. Write vector equation. Always start with what you're trying to find. And then 3, substitute and solve. Okay? Everybody could try that for me? What's your signs, right? -1 plus 3. Try this. I believe you should be completed with that now. Are you? So you want to find MP. Yeah, thought so. So, well, we know from our diagram, right? Always write where you have from the diagram. N is -1, 2, right? And NP is 3, 5. So if I want MP, I have to go from M. You've seen it in the diagram. You have to start here, go to N, and then from N to P. Mn is given as -1, 2. NP is given as 3, 5. So if we add these, -1 plus 3, 2 plus 5, what will we get? 3 take away 1 is 2, 2 plus 5 is 7. MP is equal to 2, 7. Did everybody get that? Drop a Y if you did, or 1. Yeah, Leah. Nice. Shiniqua. Dominique, Solano, Bakari. You guys get any hang of it? Yeah, Shaniqua, good. Dominique, Solana, Dakari, you guys all right with this? We're gonna do another. You got the wrong answer, or you understood? You understood what you do, and you had a little error with your calculation, or you don't understand it? Did you see Mike's too? Okay, okay. Calculation. Dakari, you all right with it? Pay attention to your signs, right? Gonna do this one for me. Find K, G. Right, remember again, one. State what you have from the diagram. Two. Right vector equation. And three. Substitute and solve. Right, and we can out kg from. Try that one out. All right, let's look at this one. So we want to find kg. So we always state what we have, right? It's a good habit. So it's easy for you to just look at your key. I call it my key. So I know what values I have, especially after I write my vector equation. Let's make sure and write this in the correct order, right? So we have J, L, and that's 3, 5. Pay attention to the direction of the arrow. L, K, -1, -6. Right? We want to find K, G. Vector equation, we start at K, and our common point is the L. So K to L, and then L to G. Right? So we're starting at K, ending at G. Always double check to make sure your vector equation lines up like that. Then we look here. So sorry, I had this. I have this back to front for you guys. My bad. My bad. Sorry. It should be J K. Sorry. Set all up here. Although you could work it out like that, but I'm already I was going to show you all that after. So you're going from J to K, so it's J L plus L K. All right, so JL is my 3, 5, and my LK is in -1, -6. Right? JK is how I want it to be. we're gonna get 3 plus -1, 5 plus -6, right? And that's going to give us 3 minus 1, 5 minus 6. 3 take away 1 is going to give us 2, 5 take away 6 is going to give us -1. And that's how we're going to get G key. Now, everybody okay with that? Yeah? Well, okay with us. 2 -1. Yep, that's correct. Solana added. Right, excellent. All right, so I just want to show you all something really quickly before we go. And that's changing directions, right? So let's say I have these vectors here. X, Y, and this is 2, 3. And this is LM, and this is equal to 4, 5. And what's another one? Let's say KC. And that's equal to 1, -5. And one more, TR. And let's say that's -2, -8. I want to show you how to change direction. So let's just say, for example, like that last question that I had, right? Let's just say that after you're writing a vector equation and you look at what you have on the vector diagram, you need to change the direction of the letters. What I mean by that? Like instead of, let's say my diagram has X, Y, but in my vector equation, I need to represent YX. Or I need to represent ML instead. Or CK instead. Or RT instead. Right? So what essentially happened there is we have these vectors here, but we want to change the direction. Right? So this is changing direction.
Excuse me, sir.
Okay.
So if they don't give you like a shape to follow the direction, that is how we're supposed to do it?
Like what I have here right now.
Yeah. Yes, sir.
Most of the time you'll get a shape. If not, you'll have to draw your shape. You draw your triangle. So you'd usually have the 3 letters and you'd know that, you know how you have to connect it. Understand? Just 1 second, right? Right. So usually you would have a diagram to work with, so you'd see the direction is going. But sometimes, like I'll draw a diagram and show you. Let's just say I have X, Y, Z, right? And I'm going let's say we go in X, Y. Right, let's just assume that we have this. And X, Y is 2, 3. Right? And XZ is 1, 4. And I ask you to find YZ. Right? Now, this is where that thing I was telling you about, where when I used to do this, if I want to do YZ, right, I would start by writing the Y, putting the Z here, putting my add sign, and I know that the point in the middle after our QF junction, my QF junction, if I starting at Y and I ending at Z, my QF junction here is the X. Everybody agree with that? X has to be the middle term amongst those 3. Does everybody agree with that? Just drop out 1 quickly in the chat, but if you agree with that. I have to find YZ, So I write my vector equation. And my vector equation, if I write in y, z, I'm going to write it over again in case you missed that. So I'm not looking at the diagram right now, right? I am just writing my vector equation. This is how I usually approach it. So I have to write y, z. That's what I have to find. I'm starting at y and I am ending at z. I must have a common point in the middle. Based on my diagram, I'm starting here and I'm ending here. But my common point has to be this x. So I want to travel from y to x this way instead. And then from x, I'm going to travel this way instead to z. Does everybody see that? In order for me to write that vector equation, x has to be my common point in the middle, my QF junction. Is everybody seeing that?
Yes, sir.
Yeah, everybody, right? Solana says yes. Julia, Leah, Dominique. Is Dakri this? The car is still no, it's not. Everybody, yeah? Okay, good. Now, I wrote the vector equation, but check this, right? Let's write what we have. I have, now look at the arrow. This arrow is going x to y, right? X, y is 2, 3. And I have also x to z. Look at the arrow here, this arrow here, right? You gotta pay attention to the arrow in the diagrams they give you. This is going x to y, and this is going x to z. So I have xz now is 1, 4. But my vector equation, I don't have a xy. I have the opposite direction, yx, right? So now, how am I going to do that? So to get yx, we change in the direction of xy. To do that, if I want to get yx, I am just going to make the entire xy negative. That's how we change the direction of a vector. So yx is equal to negative xy. So minus 2, 3. And what you do when you have a minus sign outside of the bracket, you multiply everything in the bracket by the minus sign. So I get negative 2, negative 3. That's what yx is, the opposite direction of xy. So now I could actually go on and work out this, because now I have a value for yx. Right. That's not how I want to move this around a little bit. Right, now I could go and work this out. So check what's going to happen here now. My vector for yx is negative 2, negative 3, because I'm traveling in the opposite direction to what they gave me. They told me the vector xy is 2, 3, but I need to use yx, which is in the opposite direction. So I change it to fit my purpose, right? To do that, all I'm going to do is just to change a vector, to change the direction, is you put a minus sign in front of it. xz, I do have. xz is 1, 4. 1, 4. So now I add negative 2 plus 1, negative 3 plus 4. That's going to give me a negative 1, and this is going to give me 1. 4 take away 3. So my yz, the vector yz, is negative 1 and 1, right? Now here, this is a change in direction. All you do really is you just put a negative sign in front of these. So this becomes minus 2, minus 3. Same thing here. Put a negative sign in front of it. Everybody understand that? And even like in a case like this, if one of the numbers is negative, then you just use the same rules from algebra, negative 1, and this will become positive 5. Same rules from algebra. This is negative 2, negative 8. Put a minus sign in front of it, it becomes positive 2, positive 8. You multiply the contents of the bracket by a negative sign. Yeah, everybody okay with that?
Yes, sir.
Yeah, makes sense, right? All right, guys. So that's gonna wrap up our session for today. You guys learn how to work out resultant vectors now, right? I'm gonna look at something called position vectors next. And then I think we're gonna just get into the past paper questions from there. All right, so that's the next thing now we're gonna do. Position vectors, which is more or less the same thing. It's just with position vectors, it would usually be on a graph and it starts from the origin. So it starts from 0, 0. All right, so let me save this slide here so I can send it in the group for now. But they're gonna take up everything now we had from before, right? So just skim past that. Session 2 vectors. And I'll just put check the end for new content. And our recording would be up and ready latest by